Hi all, good to be back with you again. This is the next video in my series of two-dimensional geometry, and today I want to deal specifically with circles. Circles are one of the most interesting relationships that we have, and I want to be able to take those a little bit further for us and do something. Now I've got a really fancy thing in the middle over here, right? It's simply a bunch of circles. If you look carefully, you'll see that they're vertical circles and horizontal circles. The vertical circles all have the same radius, and the horizontal circles increase in radius, and we build an object. So the important thing here is that in two-dimensional geometry, right, we use that simply to create three-dimensional objects. And this thing is called a horn of torus. And its definition is very complicated. It's a surface of revolution generated by revolving another circle in a three-dimensional space about an axis that is coplanar with a circle. That's really not important. What is good for you to understand is that this is how we start creating three-dimensional objects, is by understanding the properties of two-dimensional objects. And one of the most interesting ones is circles. Right, now, recently someone asked me, Wayne, what does geometry mean? I never thought about it, so I went and looked it up, and it turns out it comes from two words, geo and metri, and these are Greek words where geo means earth and metri means measure. So it's to measure earth, and the Greeks started doing this because they really needed to understand how to measure things, because the moment that man went from living in simple huts that took no planning to build, and they started creating in other structures, right, and they started building big buildings in the Parthenon and all those wonderful constructions that we see in Greece and places like that, they needed to be able to plan. And to be able to plan, they needed to understand the mathematics of the shapes that they envisioned. So, that's Pythagoras on the left, all right? He was an important Greek guy. It doesn't matter whether they were Greeks or Romans or Egyptians or Mayans, right? That's a moot argument. Let's call them the ancients. The ancients needed to understand a lot more about mathematics than what was obvious. So, Pythagoras himself needed to measure things, and he's one of our most important ancient mathematicians. He was a Greek, right, and he needed to measure things. Let's get on with circles. All right, this is a lot more interesting than anything else. Okay. By now, we know a lot of our common shapes. We've been through that. We know that we use a plane for drawing two-dimensional shapes on. That's just a piece of paper to draw things on. So let's go ahead and draw some circles. And if we draw a circle is just an infinite connection of joint points the same distance from a specific point. So if that little purple dot in the middle of your screen is the point or the specific point that they're talking about, right, we just have a distance from that. We take an arbitrary distance from that, and that we call a radius. And if we connect all the points at the end of a radius all the way through and all the way around, we have a circle. Right. Another important thing that we need to know about circles is that if we draw a line straight through the middle of a circle, it'll always be the same length because the radius is the same. Right? And that's the middle point of the circle. So if we do that, we call that a diameter. And then the circumference, and I say that word softly, circumference of the circle is the circ from circle, and it's like having a fence around it. And that is the distance that you can measure around a circle, and that is the circumference. And those are three very, very important measures, three of the most important measures that we have in understanding circles a bit better. Right, so if we take a radius and we move it up, right through an arc. We move it up and we put it over the one side of a diameter, right? And that's sort of half of the diameter if you think about it. Right? We'll call that the first radius, and then we'll move the radius again and we'll move it to the other side, through the other arc, so that we form a straight line with our two radii, right, along the diameter, and that's radius 2. Now you kind of know, right, and this may be boring to you, but those radiuses are kind of the same. But how do we relate this to diameter? Diameter must then be equal to the first radius, and we add to that the second radius. First radius plus radius 2. Right? And since they're the same, we can now quite comfortably say that diameter must be equal to 2 radius. And that's the first important relationship that we need to know about circles. Right. So, let's look at that. Radius as a relationship, two of them equal a diameter. And the radius itself must then be half of a diameter. And we know this is right. We can see that it's right. It feels right. Right? If radius is half a diameter, then two radiuses must be a whole diameter. Good. That's the first relationship that's really, really important. Now, what the Greeks soon realized, right, is that this was not enough. We need to know more about circles to be able to plan better. So they wanted to find out, how is there another relationship? Can we relate the circumference, or the fence around a circular object, circumference, can we relate that to diameter and radius? Because those were enough. And this is what this lesson is actually all about. They needed to know more. So let's draw some circles. Now, it's very, very important, right, that you actually do this yourself. Caregivers, parents, please make sure that the kids draw this for themselves. And because once you've proved something to yourself, kids, right, you never have to prove it to anybody else. You can listen to me. I'm boring, right? I don't speak very well. I'm really a boring guy. But if you've proved something to yourself, you don't have to listen to me. You'll know it for the rest of your life. So take a compass. That's kind of what a compass looks like. The other models of compasses, this is a really cheap one. Make sure that the points are good so you can draw something, because we are going to measure some things about circles. And then I want you to draw circles. How do you draw a circle with a compass? It's actually not as intuitive as what it might seem. The best way to do this is to just put the compass down, right, on a top, put the point through the paper, and then rotate the paper while the pencil is on the paper. And that's probably the best way to draw circles. So we now know diameter is 2 radiuses, and a radius is half a diameter. That's our first most important relationship regarding circles. Now I want you to draw and cut out 3 circles. Right? Use thick paper if you can, right? And draw the following circles. So we're going to use centimeters simply because it's a comfortable distance. Inches is a bit long, and it doesn't stretch. Your compass doesn't open up that far, and millimeters is too small. It doesn't give you an accurate reading. So let's use centimeters, because that's a pretty good one to use. It doesn't matter what you use. It's just units. It's units of measure. So we'll draw our first circle at 3.5 centimeters of radius. In other words, 2 times that will be 7 diameters. Okay? So 7 centimeters in diameter. Right. We'll draw the second circle, and we'll just double it up, right? Because that 7 is quite important. We'll double it up, double the 3.5 centimeters to 7 centimeters, or a 14 centimeter diameter. And we'll draw a third circle, and we'll set it at 10 centimeters, right? And we'll draw it at 20, and that'll give us a diameter of 20 centimeters. Right, you can stop the video now and do this, because it's quite important for you to do that. You can listen to me, but I'm boring. Rather prove it to yourself, because you'll never forget it. So stop the video now, or come back to it over here, right, once you've drawn those 3, and let's do some measurements. So break. I assume that you've now come back to the video, and we're now going to measure certain of those things. We've cut out the circles with a scissors or a blade, and we're now going to measure these circles. You cut them out, get them ready, and measure them. You got your 3 circles, one of diameter 7, one of diameter 14, and one of diameter 20 centimeters. Those are your 3 circles, and you now want to measure the circumference. Remember, the circumference comes from the word circle, and the fence, so it's the fence around the circle, this green line around the circle. How do we do this? It's actually pretty simple. You put your ruler down. Now, this is certainly not to scale, so don't worry about that. Okay, but it's the principle that I want to explain. You take your first circle, you do the same process for each one of the 3 circles. You put the circle down, draw a line, a diameter line, in other words, a line through its center, right, and put an arrow at the top, at the top, like I've indicated over here on the piece of paper. Now, when the arrow is at the top of that line, and you've aligned that to the 0 point on your ruler, so you put down a ruler, okay, all you do now is you rotate that circle, the first circle, rotate it all the way until the arrow is at the top again. Now you can mark that point and say that is how far it was. I would just take out a little Koki chalk or something and just measure it, mark it over there, and now you want to check yourself. So what you do, right, is you roll it back. And if you roll it back carefully enough, you're going to end up exactly where you started. Right? Everybody happy with that? So we roll it. Okay, to where we want to start, and we bring it back. And if we've done it accurately enough, right, we're pretty sure that we've done it correctly. Roll it, check it, do it a couple of times. It might take a bit of practice, you get it right. Do it for all 3 circles, and that's the summary of our circles. And now that you've measured the diameters, right, put them down. Correction, that you've measured the circumferences, put them down. And you'll find, right, without a word of doubt, that if you've done this accurately, the one that has a 7 centimeter diameter has got a 22 centimeter circumference, and the 14 has got a 44 meter circumference, and the 20 centimeter diameter has got almost 63 centimeters, somewhere just past 62 point something centimeters. It's almost 63 centimeters in circumference. And now that we've got this, we can start making some other calculations and start looking at these numbers in a little bit more detail, right? Because what we're trying to do is find out, is there a relationship between C, being the circumference, and D, being the diameter, or R, because D is just 2R, right? So we're trying to find out, is there a relationship between diameter and circumference, and what is it? Can we find something that we multiply by D to give us the circumference? And let's have a look at what that is. Okay, so in the 7 centimeter diameter, we had 22 centimeters of circumference. And if you take the 7 and you divide the 7 into 22, you get 3, right? 3 times diameter plus 1 centimeter. Isn't that interesting? Because 7 goes into 22 21 times, and there's 1 remaining. We're working in centimeters, so this remainder is in centimeters. Very interesting. If we look at the circle 2, which we measured, right, and we know that it was 14, and we measured the 44, and then in the red area here, I'm saying, what does this mean? You say, well, it's 3 plus 2 this time. Okay, and we carry on with this. Let's have a look at what this means. So second circle, firstly, the second circle is simply 2 times 7. So we've doubled up the diameter, and guess what? We've also doubled up the circumference. Now that's a very important relationship. It appears to us at this point in time that if you double the diameter, you also double the circumference. Very, very important. Okay? And this means that we have a fixed relationship. Diameter is related to circumference in a very fixed way. And this is an epiphany moment in mathematics. The ancients looked at this and said, oh, wow, we now have a method to relate diameter to circumference. And we need to understand that a little bit more. So let's develop the mathematics a little bit further. So I'm taking you through the journey of what the ancients did. So if we look at the first circle again, 7 centimeters in diameter, 22 centimeters in circumference, and that was a ratio. The ratio of circumference to diameter, right? So this is just a way we write a ratio, was 22 to 7, right? We carry on with that, okay, and we did the 14, where we doubled up the diameter, and we doubled up the circumference in the same way. 3 diameters plus 2, we're going to get to that a little bit later. That was 44 circumference and 14 centimeters in diameter. And guess what? If we divide both of those by 2, we're back to 22 to 7. Wow. Now, let's assume we drew a fourth circle. It was a little bit bigger, right? So we made it 21 centimeters in diameter, and that was 66. It would have been 66. Promise you, it would have been 66 circumferences, and that would have been the relationship. And 66, once again, divided by 3, and 21 divided by 3, ended up with the same ratio as 22 to 7. And that's a very, very important number. 22 to 7 is the ratio. Now, a ratio is a funny thing, right? Because it's constant. If your ratio is the same for various figures, it must be a constant. So circumference, or C, is related to diameter in a very fixed way. And this way is 22 to 7, and that is what we in mathematics call a constant. Let's have a look at this a bit further. The way that you can deal with a ratio is you can divide them like that. It's the same. A 22 to 7 is the same as saying 22 divided by 7. So let's just replace 22 divided by 7 for those three. And that's the constant, same way in which things are related for circles. And those things that I'm talking about are circumference and diameter. 22 divided by 7. Right, so let's have a look if we can, if we use this formula and we recalculate, because we need to check our maths, we recalculate the circumference from the diameter. We know that when we had a diameter of 7 and we had this 22 divided by 7, then we know that if we take the circumference and we say it's 22 multiplied by 7 or 7 multiplied by 22 and divided by 7, because that's our ratio. So here's our ratio. 22 divided by 7. We took 7 diameters. This is the constant, 22 to 7, and we did that sum. And if you do this on your calculator, you'll find out, hey, this is just 22 again. Okay, and then with a diameter of 14, circumference would have been 14 multiplied by 22 divided by 7, which would have been 44, and that's what we measured. Okay, so it agrees with those two. And for the circle 3, which we couldn't measure exactly because it didn't work out quite exactly, right? Where we had 20 as our radius multiplied by 22 divided by 7. Remember, these are our constant factors. These are our constant factors. We get an answer of 62.85 and a whole bunch of decimals after that. Very, very interesting. Okay, and so almost 63, and that's what we measured when we built it. Right, number 4 with a diameter of 21, then C would have been 21 multiplied once again with this ratio 22 divided by 7. Okay, and we end up with 66, and that is the perimeter or the circumference. Those are the same words, right? The circle fence or the circumference is 66. Right, now this means something. The ratio C to D is the same, right, as writing 22 to 7, which is 22 divided by 7, which is the same as saying 22 upon 7. Now, do me a favor. Break the video now if you don't have a calculator with you. Get hold of your calculator and start the video again. All right? And let's say, right, we started our video again, and we've taken 22, we put it into our calculator, we divide by 7, and we get a number that looks exactly like this. Now, most calculators can only go to about the red. All right, some of them go a bit further, but guess what? Pi is indeterminate. It carries on forever. There are websites in the world that can display 1,000,000 decimals of pi, and it never repeats, and it's always smaller. It's an irrational number. Okay, so it's a real number, but it's an irrational number. We don't really know what it is. And we've called that ratio pi. So that 22 upon 7 is a very important ratio called pi. So let's rewrite some of our formulas. C equals, C being circumference, D is diameter, C equals diameter times 22 divided by 7. That is a constant. The 22 divided by 7 is a constant. And we know that that number is 3.141592, etc. So circumference is always the diameter multiplied by that number called pi. So circumference is 2d pi. Or, since 2d pi actually is, since d is 2 radiuses, we can replace the diameter with 2 radiuses. Now, that's very accurate and that's correct, but we actually do it slightly differently in mathematics. What we do is we first write the numbers that we know in front, and then we write a constant, and then we write the variable, right? In this case, the variable is radius. We have a circumference. We have a variable that's radius. This is our formula, and our formula reads like this. Circumference is 2 pi radius. Circumference of a circle is 2 pi radius. Circumference of a circle is 2 pi radius. Get to say that to yourself a couple of times, because you'll actually never forget that as long as you live and as long as you do mathematics. All right? The circumference is 2 pi radius, and that is the actual formula for circumference. Now, let's look at this again. All right? If circumference is 2 pi radius, right, and 2 radiuses is a diameter, then circumference is diameter times 3.1415, etc. Now, what happens if we take that diameter and we say it's 3 diameters, right? 3 diameters plus 0.14. So we just take the decimals and we say diameter times 3 and diameter times 0.14. This is the same. Okay? So That tells us a very interesting relationship. And we want to try and prove that relationship to ourselves. Now, if you go back to your circles and you take a piece of string and you cut them out in the length of the diameter, let's say the largest circle, okay, then you can follow what I'm going to show you now. All right. So if we take a diameter, we take the diameter of the circle, right, and we take up that piece of string that I talked about, and you cut it out and you lay it along the outside of the circle until you get to the end of it, and you say, right, that's one diameter. And you pick it up and you lay it around again, around the perimeter of the circle or the circumference. Then you say that's 2 diameters, and you lay a third one like this, and you get to 3 diameters. And you then measure that little bit that's left. You'll find out that that is 0.1415, etc. diameters. Okay? And that's what it actually means. It means that the diameter, right, is 3.1415 diameters is the perimeter or the circumference of any circle. Very, very important relationship. Great. Now, let's summarize, because this is what we know about the relationships of diameter, radius, circumference of circles. Diameter is 2 radiuses. That means a radius must be half of a diameter. Circumference is diameter times pi, or 2 radiuses times pi, because diameter is 2 radiuses. And circumference is this 2 pi radius. Circumference is 2 pi radius. Say that to yourself a couple of times, because you'll never forget that. Now, the only measure that we haven't got over here is area, and I want to leave area. That's the formula for area, by the way, but I'm going to prove that to you in a future video. Area is pi radius squared. All right, notice again that we first write our constant, right, and our constant relationship being pi, and then we write the variable radius. So area is pi radius squared. When we get to understanding how we calculate the area of triangles, right, from that we will deduce that the area of a circle is pi radius squared. And I look forward to being able to do that with you. Right, so that has been it, right? Maths for You Today is our official name. Right, I've had so much interest in what I'm doing right now that I've got a whole network of teachers together, and we're going to start delivering very specialized services. And I'll keep on doing these videos, and maybe some other people will join our channel with the videos. Like or dislike the video, right? You can subscribe, and if you put on the bell, you'll be told every time there's a new video. Right? Become a patron. Patron will support what I'm doing over here. I need to be able to pay the teachers that want to join our network some money. Right, so we're on Patreon/Common Core Math. Go and have a look for us over there, and you'll find us. To join us is only $5 a month. That's not the end of the world, and you're going to get a whole bunch of extra services at our official website, which is www.mathforyou.today. Patreon links to that for you, and you can see it, and you'll have a lot more benefits over there. By the way, I'm giving out tokens for people to have a look at what we're doing in our specialized services over there, so go and have a look. Thank you very much, everybody. Remember, think positive, guys. Maths is great. Maths, the greatest enjoyment you can get is to be the boss of maths. Right? Maths is great. Be the boss of maths. Thank you very much. And bye-bye.